Hello, welcome to RECcon21, the first ever RealEstateCore conference. So it's going to be a 3-hour session with all the information and resources that you need to start understanding and using RealEstateCore. So my name's McHale, I'm the MD of Memoori Research and I'll be your moderator today. And joining me here in the studio, we've got Karl Hammar and Erik Wallin, both co-creators of RealEstateCore. Welcome, gentlemen.
Thank you.
Thank you.
So before we get started, a little bit of housekeeping. There's going to be a series of presentations today, and feel free to ask questions. So we ask that you put those in the chat and they'll be answered by one of us or the presenter. And beyond that, also the presentations are going to be made available online. So if you go to the RealEstateCore website afterwards, then they will be online at some point. So to kick things off, guys, I think first of all, I'd like to come to you, Karl, and really ask, why we're here today.
Well, yeah, so we're here to talk about RealEstateCore and, as you said, how it works and why you should use it. And I think we're at a really sort of interesting time where we can make a lot of impact with this work. So if I may make an analogy, if you look back and think of how the computing business started, way back, you would have a whole bunch of different computer vendors, and they would each have their software stacks and their operating systems, and it would be difficult for software providers to reach a broader market, if you will. And in purchasing, you had a smaller selection of software to choose from because everything was sort of specialized for the target platform. And we're and then things started homogenizing and standardizing on a couple of operating systems, a couple of technical standards, and now we have this huge ecosystem of iOS and Windows and macOS and so forth. And I think we're at the same point when it comes to buildings, that these smart building systems, they're typically custom made for a single building or for a small portfolio. And there's a little reusability and there's little economic ecosystems that span across the entire field. And that's what we're hoping to enable by building this standard so that you can actually reuse software, and you can exchange data between buildings in portfolios and so forth. So we're hoping to contribute that, and we hope that RealEstateCore can be part of that solution.
Exactly, and as we said, that's the main focus of today. I think we want really to give people an overview, but also a little bit of deeper knowledge, right, and understanding, so actually they can start using this and also contributing. So I guess that contribution part, right, that brings me on to you, Erik. Why create the RealEstateCore Consortium?
Well, it all started out as a work load sharing project. It actually started out among a couple of different property owners and academia, and as well as a couple of vendors where we saw that we're basically solving the same problem over and over again. We were reinventing the wheel. So RealEstateCore is actually the result of trying to make sure that we are splitting the load among us, and I mean with the aim of actually putting an API on the buildings, making the buildings work together with the smart city. I mean to actually get the chance to make a smart city and connecting all the buildings. So the reason is to just reuse all the data you have in the building and make it available. And as Karl said, to actually industrialize the built environment.
Great, okay. I mean, also today, are we going to discuss who these consortium members are, and also are there some new people joining?
Yes, I would like to make some announcement with the recent members in RealEstateCore. It is Granlund Oy of Finland, that are working in the real estate and construction sector, as well as Microsoft Corporation, that are a member of the RealEstateCore just recently, and also Sweco AB, that is also working within European engineering.
Okay, a couple of companies there people may have heard of.
Heard of, and also of course we have several other members, and but I mean, you will see them in this during the day, and of course you have the membership roster on our website.
Great stuff. Okay, so let's maybe go through the agenda for today. So, of course, we're going to go through a little bit more of introduction here at the beginning, but then we've got basically the main part of today's agenda is 6 presentations. So the first one, I think Erik yourself is going to give, and that's going to be what is RealEstateCore and why is it needed? Then after that, we've got an excellent presentation from a guy at Microsoft. He's the partner GPM Azure IoT, Bert van Hoof, and he's going to be giving a presentation about called Hello Domains, Goodbye Industries, how Microsoft leverages RealEstateCore. After that, it's over to you, Karl, who'll be giving a presentation about getting started with RealEstateCore. And again, I think that's a really important part of today's program, because I see this really as not just an introduction to for people to RealEstateCore, but also trying to get them to use it as well, right? Then we're going to move on. Basically, then there's going to be 3 presentations, which are really about how other companies are using RealEstateCore. So the first one will be from YIT, who are a construction company. That's going to be called Using RealEstateCore for the Smartest Building in the World, 2021. Then another one from ARC, US Green Building Council, David Witek, which is about how RealEstateCore enables automation of LED certification. Excuse me, LEED certification. And the final one is from David Helleberg, who is a researcher, energy researcher at Academic Hoof. And that's about conceptualization of AI into indoor climate as a service based on RealEstateCore. So that's the agenda for today. I hope everyone's going to enjoy it.
And just before we're starting, we just want to make a special thanks to Vasakronan that is lending us and letting us use this wonderful venue, the Sergel House in the heart of Stockholm. And this is a fully RealEstateCore encoded house. So we have more than 15,000 sensors and actuators, and there's more than 10 different systems that are interconnected and RealEstateCore enabled. And also extra fun is to say that this has the 2nd highest LEED scoring ever, this building. So it's extremely sustainable building.
Wow. Yeah, let's get started. Okay, so let's start with, of course, our first presentation, and this is called What is RealEstateCore and Why is it Needed? And this is going to be given by Erik Wallin, who's the founder and chairman of the RealEstateCore Consortium, as well as Idun Real Estate Solutions, that makes digital twin software based on data ontologies for real estate property owners. Erik is an active researcher within the field of semantic technologies. Erik's goal and passion is to create semantically connected self-learning systems, i.e. to contribute into making the smart city come true. So over to you, Erik.
Hi, my name is Erik Wallin. I'm the chairman of the RealEstateCore Consortium. I'm going to talk about what RealEstateCore is and why it is needed. RealEstateCore is a common language for property technologies to talk to each other. It's based on blueprints, on BIM, building management system, also elevators, access control, etc. Systems that are basically installed into the building, and also the usage of new IoT systems to be able to retrofit buildings inexpensively to gain new capabilities, as well as different kinds of business systems, invoicing, facility management, different kinds of planning systems. So when we started out RealEstateCore, these were the kind of domains that we sorted it into. And of course, the feeling got directly that, are we just doing a classical engineering part here right now? We are going through the available standards, figuring out that none of these are really perfect for us. So let's invent yet another standard. Let's give the world one more standard. Well, we are definitely guilty to that. But what I think actually justifies it is that when you start looking at these technical standards or clusters of standards, you see that there is very low or almost none support for the business side. There is no contract object or lease or tenant object in these different technical standards. Of course, there might be some exception, but basically you could generalize and say that. And this means that you have systems in your buildings that are basically designed only to solve one different problem. I mean, to run the climate, building management systems and the building, to plan the building of the system and having some sort of a documentation, etc. So I think that RealEstateCore is definitely solving this problem of adding this interconnection between the business side of running and owning and operating a building, and also how you can use the different sensors and material that you have to do this. And then the other part as well is that RealEstateCore is based on semantic web technologies, and with a very few exceptions, the most standards that you find in these different worlds are tag-based or based on simpler, older categorization standards. So RealEstateCore is really helping to push the property business into the knowledge graph digital twin world. So if you're looking a little bit more specifically, why is RealEstateCore needed? The mission that we have in the RealEstateCore Consortium is to make all of the world's building into ready and able inhabitants of the smart city. Basically, how can we put an API on the buildings that can interact with the smart city? RealEstateCore will not be solving all of the challenges and all the possibilities regarding the smart city domain, but we can definitely make sure that the buildings, which is a large part of a city, will be good inhabitants and interact with the other parts of a city. So specifically, if you're looking at the smart city, it's of course we need to maintain the sustainability in our buildings, but definitely increase it. And this is not just conserving or reducing energy usage, but also how we're handling waste, how we're handling transports. I mean, everything that is a scarce resource for the buildings and the city. And secondly, I think it's extremely important that we make sure that we empower the tenants, the people, the ones that are actually working and are using the buildings, that we are safeguarding the indoor air quality, we are making it possible to add new services, interplay with public transportation, with restaurants, etc., in order to optimize the operation of the building and the smart city. And third, I think this is something that you don't talk too much about, but I think a huge stop is that everyone sits on their data. So we really need to facilitate the public-private cooperation and enabling the data sharing, making sure that the property owner can be very secure of what kind of data are we giving away from our building. It will not have an impact on our business. And at the same time, the people knows that their privacy is safeguarded. I think this will probably be one of the major stops when it comes to start connecting different buildings and different services in the smart city. And this is really a silo maker if we don't solve this one. And RealEstateCore gives the property owner a very good overview of what data are we sharing and to whom, and we can control it. Of course, then also helps with GDPR compliance. So a little bit about the background. RealEstateCore was founded, it's almost about this time 4 years ago, it actually started to find the shape that we are seeing right now. Officially it was founded in January of 2018, so that's almost 4 years from now. The founders were Idun, that's where I work, Vasakronan, Wilhelm and Akademiska Hus. They are all large property owning companies within different domains, office and retail spaces, residential, educational spaces. So they were complementing each quite well, and they have very large portfolios together and by themselves, as well as academia represented by Jönköping University and RISE, that's the Research Institute of Sweden. So we had a very good mix of actual stakeholders, property owners, as well as academia, and then Idun, where I come from, which has actually a foot both in property owning and in academia. The principles of RealEstateCore, the most important principle, the reason for the foundation was that was actually Søren Sandell at Vasakronan that actually reached out to a couple of his colleagues at other property companies, realizing that they were trying to solve the same kind of problems when they're scaling up in the digitalization efforts. So RealEstateCore is very much a workload sharing project. We are trying to make alignments and making sure that we are sharing the workload among the different partners. It's basically don't reinvent the wheel. Don't do it in different property owners or different places. Very early on, we also said that this needs to be non-profit. It needs to be no license fees. Well, I mean, basically, how was internet built? It was built on RFCs, and there is no licenses to be paid to use internet, to use TCP/IP and HTTP, etc. And also it needs to be open source, and it has to have very permissive usage. I mean, the open source we chose was MIT license, and that basically means that you can do whatever you want with the code. You can copy it, you can use it commercially, you can change it, and this is also a very important principle, that it's not by binding someone to it, it's rather that you want to use it. That should be the foundation of RealEstateCore. RealEstateCore is governed by a board, a formal board that presides 4 times per year, and it consists of the founders. Then RealEstateCore has a technical committee that has the ability to start technical subcommittees where different development and different domains is happening. So the board gives directions to the technical committee, and the board is the final approval of major changes, like when we're doing breaking changes and other things. A brief history of RealEstateCore. It was roughly 5 years ago that it actually started to take shape. It had been we were a couple of people that have been working with semantics for even 10 years before that, and building systems, but it was here it started to take its formal shape. And I'll just take a couple of important milestones. We said before, the end of January 2018, then the consortium was formally instituted. RealEstateCore is a non-profit organization registered under Swedish law. Then, roughly 4 months later, the first RealEstateCore was published as open source. I think it was 2.3. We had already been done some work earlier then. We started out quite fast to both work with academia and different kinds of governmental sponsored research institutions in setting up funding for this. So we actually had resources. So we had resources for ontologists and developers doing just core RealEstateCore work. very much thank you to the KK Foundation, Kunskapsstiftelsen, as well as to Vinnova for the different kinds of funding, and probably lots of other institutions and people as well, but specifically to your institutions. And we also made some significant moves. We have our canonical RealEstateCore ontology paper was published on the International Semantical Web Conference 2019. If you are writing papers, then that's the one to put in your reference. We also started to work with one of the ones that we saw were like forerunners that both had a semantic approach and were really getting industry traction, and that's Brick Schema and it's W3C Bot. That's World Wide Web Consortium's building topology ontology. A little bit more about those later. But we made, together with them, official alignments. An alignment in a semantic web context means that we're doing this kind of thesaurus between the two different languages. That means that programmatically you can a RealEstateCore system with the right programming can read data that is encoded in Brick Schema and vice versa. Also, at these early days, we got in touch with Microsoft, and I mean we are in contact with the other large cloud providers as well. But Microsoft was very interested in our RealEstateCore work, and we got to work quite close with them. And I know that there will be more information about that later today. But what happened last year, 2020, was that we released the RealEstateCore 3 versions. Then we had breaking changes from the 2 versions, which was then, I mean, a much better version. I mean, it was much more mature, and as well that Microsoft Azure Digital Twins adopted RealEstateCore. That meant that if you are running Microsoft Azure Digital Twins, then RealEstateCore is already pre-installed or heavily recommended to use. So I know that Karl Hammar will later go into more details about RealEstateCore, but I'm just going to give you a little bit overview of RealEstateCore and why I think it's very, very smart. And this is very much thanks to Karl Hammar and Per Karlberg. Here you can see the BIM, BMS, IoT, and business sides and how they are interconnected. So that is the ontology that is made in OWL, web ontology language. And then that ontology is being used by small software tools that you can automatically generate an open API specification that is formerly known as Swagger. So you generate the REST API YAML files ready to use for your platform, your application. Also generate automatically a JSON schema for edge interfaces when you have more lightweight communication, such as with BMSs or IT devices. And also you can create directly in Azure Digital Twins, a digital twin description language format directly from the RealEstateCore ontology. Or you can create any other digital twin platform ontology. This is all open source. All the tooling to do this is open source. And why is this so clever? Well, because when you make a change, when we release 3.3.1 as an example, if there's some minor addition or bug fix, then you just regenerate all of these important YAML files and all the other important interfaces automatically. It saves lots of times and removes extremely much manual errors. You increase the quality and you save the time. And other use cases are that you might need to extend the RealEstateCore ontology to support your specific system. That might not be a part of the RealEstateCore ontology yet, but then you can load that as an extension, an extra module. Imagine that there would have been like a red bubble here with some proprietary ontology, some proprietary definitions that are needed to solve a specific problem. And then you can just generate this and you can get out YAML files, you get all the specifications out directly. And having these, the ontology, the standardized API, the message format, that's the edge interface basically, then you have all the components that you need in order to actually make an ecosystem that lots of people can do. So everyone that is using RealEstateCore and is RealEstateCore certified are then following and abiding to using these tools and using these definitions. And we touched upon that a little bit. Another part of RealEstateCore was that we saw that it's extremely important to align, not trying to convince everyone to speak RealEstateCorean, but rather to align, to make it easy to make it easy to use RealEstateCore. You don't have to choose. Should I use Brick, or should I use RealEstateCore, or should I use Haystack, or should I use Google Digital Building or something else? But rather that you can use both, or you can use them using alignments. Alignment is a technique in semantic web technologies where you make these digital files that makes it possible to programmatically interpret data between two different systems. So we have been working quite close with the building topology ontology. I would say that is my interpretation, next generation of BIM. like the semantic overlay on IFC. Lots of BIM savvy, and I would say the leading knowledge in the BIM community are part of that room. Our Karl Hammar at RealEstateCore is co-chair in that group. We're also working very close with Brick Schema and have been working with them for more than a year, or is it 2 years soon? That we see is the leading standard for the building management systems when you need to have all the intricate details of actually designing ventilation systems or heating and cooling systems in buildings. And also that we're working very close with Microsoft. And this is not just Microsoft taking RealEstateCore. Microsoft is actually quite actively participating in the development of RealEstateCore. So it's not just taking a standard and putting it into the system, but they are actually rather also improving RealEstateCore and challenging it. And that also makes that we get lots of more use cases and usage around the world, which of course was that we didn't think of in order just to make it stronger. So, and this is not the end. We will be adding more global standards as we go along. But I think this is a really important part, that you can't make everyone speak RealEstateCorean or speak your language, but you'd rather have to make it easy for people to use it, or not being forced to choose between this system or that system. You don't need to gamble. So the end game of all of this, that is that a digital twin, a PropTech digital twin, needs an ontology such as RealEstateCore. If you're going to make a digital twin, I would strongly recommend that you're doing it based on a knowledge graph database. And then you need an ontology on top of a knowledge graph database. Another really important perspective of this is that we realized quite early on that you can't make one digital twin for all your different systems. You need to connect all your different sources of information. You need to make collaborative digital twins. Basically, you need to make a telephone book for all the different systems, like a DNS system for digital twins. And take just example, take a room. It has one ID in the IFC system. It has an IFC GUID. It has another ID in the BMS system, usually some sort of a tag. And it has a third ID in the invoicing system, fourth ID in the facility management system, etc., etc. And the more system that we're adding to the buildings, the more complex it would be. I know Vasakronan, that is using this collaborative digital twin feature in RealEstateCore, has more than 30 different digital twins or namespaces, if we're talking DNS, and that they are interconnecting using the foundations of alias ID in RealEstateCore. And basically, the end game is, of course, that we need to get portability of systems and applications. Compare this to Android App Store or Apple iPhone App Store, or running a software on top of a Windows computer or a Mac computer, that you need to have the vendors out there needs, when they are making an integration to a system, you should not be able to need to do it again and again. That will not scale. It will be extremely costly to do that. Latest and work in progress. What are we doing? What have we been doing, and what are we doing in the RealEstateCore community? Well, as I said, we are doing more and closer cooperation with other initiative standards to make sure that we are converging all different standards instead of expanding them. I mean, I think that is extremely important, that we try to converge standards. That's helping everyone, and especially if we are going to get the smart city as pick any science fiction movie. I think the foundation, one of the cornerstones of that is definitely that we need to have the same language interoperability. Some areas of interest: facility management, service objects is a new module that is coming in version 3.4, given that the technical committee approves it. That is an open process, the approval. That means that anyone can have a saying and have their arguments pro or con. Access control. Access control has been in RealEstateCore for a long time, but it's continuously evolving. As an example, Peter Häger at Castellum, a large property owner, has done a great amount of job for the access control model in RealEstateCore, and it's progressing with other players as well. Financial transactions. The more that we see that the reality for property owners are changing, that the old way of signing a lease contracts for usually multiple years have moved over to much shorter leases. You can be leasing a conference room for just a couple of hours, or you could be providing other services. This adds the demand to get the metadata out of transaction connected into where did it happen in the building. Did we have any sensor that could detect that their conference rooms were used or not? Should we do automatic billing? So I don't think that RealEstateCore will go into a financial transaction platform. There are plenty of those, but we definitely need to start looking for how can we get metadata and how can we connect these transaction platforms with RealEstateCore platforms. Demand response, that has also been energy demand response, that has also been in RealEstateCore for some while, but there's lots of work being done in more clever how you should actually interact, how the interaction should be between all different parties in the demand response chain. That's hopefully also getting into 3.4. Another thing that we have done, and here we have done it together with a couple of vendors, is that we are how do we handle all the blueprints that you have in for your old buildings, all the legacy, all the DVGs? That's one of the most common format. How can you process this? How can you make this into an internet format such as GeoJSON? So you can put this up on a Google map or OpenStreetMap or any other object, Power BI or any other visualizing tool. So here we have been working quite close to actually add RealEstateCore encoding into GeoJSON, and of course that is straightforward, but that we actually can have a recipe for how do you add RealEstateCore encoding into a GeoJSON object. Also hopefully will arrive in 3.4. Another thing that we have done is that we have created an occupancy index. And there's a link to a blog post, which is basically a white paper that describes the algorithms and there is no secrets, all the mathematics. But this enables us to take any sensor that we find in the buildings, peer sensors attached to a BMS system, AI-based people counting cameras, footfall cameras, IoT sensors, anything, and normalize this to RealEstateCore into presence that creates an occupancy index. And this, of course, makes it possible to break silos between systems, reuse all your installed sensors you have in the buildings in order to understand how the buildings are being used for planning, for cleaning, for should we do we need to run the ventilation as hard or the cooling as hard? I mean, all the people have already left the building, etc. So I'll start to round up here with some calls to actions. I would suggest that you start using RealEstateCore, both in your code, but also if you're a property owner, in your procurement requirements, that you are already requiring that you should use RealEstateCore compatible products when you are refurbishing or doing new constructions. And you can see the links to resources here. Second is participate in the community. RealEstateCore has a Gitter community where you can reach out and ask any questions and see if you can find like-minded if you have some problem or issues. You can also participate using the GitHub, but then it's more specifically on different issues. Again, when it comes to when we have something new happening, or if you find some bugs in the code. And then, of course, join the club. Become a member of RealEstateCore. You don't have to be a member to use the RealEstateCore code. As you remember, it's non-profit, it's the MIT license. You don't have to be a member to participate in the communities or in GitHub. However, if you are aspiring to become a technical subcommittee, as working in one of the technical committees or subcommittees, then you need to be a member. As an example, if you take the domain waste management, if you are representing that and you have specific domain knowledge that the rest of the club does not have, then and you really want to make this work, then it could be a good example is that RealEstateCore could start a subcommittee. The technical committee could decide to start a subcommittee and assign the chairmanship of that subcommittee to you then. But then you need to be a member. And lastly, certify your product. There are 4 organizations that can do certification of your product, so you will earn this certified by RealEstateCore. We have plans of doing an automatic tester. Hopefully, we can get that into some of our upcoming projects. But you can earn a certification from one of the 4 organizations that are accredited to do that. Thank you very much for listening.
Thank you, Erik. That was an excellent presentation. Is there anything you want to add at this point?
Oh yes. What has come up just after this recording was done, it was actually also clear that together with the Swedish Real Estate Owners Association, we will start working using RealEstateCore for QR codes and coding. I think that's a really fascinating program to how you can use digital twin IDs directly in QR codes and share them among different property owners and different vendors, etc.
Okay, excellent. Karl?
Yeah, and I just had a bit of an erratum to the presentation, which you kindly gave me too much credit. I'm involved in the W3C Linked Building Data Community Group as a co-chair, and the bot ontology is, among other parts, supported, and a lot of development work is done through that community. But I was not involved in the construction of bot originally, and I should say that credit should go to Mads Rasmussen, Peter Powells, George Schneider, and Maxime Lafrancois. So that just to make that absolutely clear.
Great.
Thank you, Karl.
just to pick into some of the points from the presentation, because I think, this is, for me anyway, going to be one of the most interesting parts of this whole thing, I think, to people to understand not just, of course, what is RealEstateCore, but really the purpose of it all, right? And I picked out one specific point that you mentioned about sort of a lack of business objects and understanding in some other technical standards. And I think for me, that's such an important point about what REC is, essentially. So, right, because REC comes from this commercial property perspective, right, and has, obviously a lot of technical input. So, is that, do you think, what the USP is here? What makes this really compelling for property owners and developers?
Yes, I think actually, our motto in RealEstateCore is for property owners and by property owners. And I think that is what we are actually addressing. That, all the other standards are made for the vendors. It's not made for the property owners. You're missing these important objects such as contract, tenants, premises. So I think that is the core of RealEstateCore, that you are actually making use of the data and then trying just to align to other standards, not make anyone choose what standard you should have, but rather interact with different standards, but just adding this kind of business dimension. And that is what I strongly believe is needed in order to actually make this this leveling of the whole industry up to the next level and start making things smart cities, smart grids, everything.
Yeah, and you mentioned choice there, of course.
Yeah.
We're not expecting or trying really to create the one standard that's going to, we're expecting or you're expecting everybody to follow, but it's another tool in the toolbox.
Yeah. To bridge. To bridge or align as ontologists says between the different standards.
Yeah. Karl, anything to add, Karl?
No, yeah, so I'd agree with that. And with that comes something that I'll touch upon in my talk a little bit later. It's that when we model these different aspects of the problem domain, we go sort of sufficiently deep to solve the business problems. We don't go any deeper than that. So, and that's in line with this, is that we get the coverage that we need in the model to achieve the business objectives. But if you need a specialized model for some very specialized subdomain, we would recommend that you use something other than RealEstateCore.
Yeah, really good point. Okay, so now time for our second presentation, which is called Hello Domains, Goodbye Industries, how Microsoft leverages RealEstateCore to accelerate time to market, enhance interoperability, and extensibility for your smart building solutions. And we're very pleased that Bert van Hoof gave up his time to come and talk to us today. He is partner and GPM of Azure IoT at Microsoft. So a little bit about Bert. He's a seasoned technology executive, recognized for starting and growing award-winning businesses across a variety of industry segments, including operating systems, imaging publishing, health, productivity, IoT, and technology areas such as operating systems, mobile apps, and devices. As Group Program Manager for Azure IoT, he is helping organizations put the Internet of Things and Microsoft's intelligent cloud to work across a variety of industries, including smart buildings and smart cities. 36 granted and/or patent pendings offer further evidence of Bert's innovative credentials.
Hi, thank you for having me at RECcon21. My name is Bert van Hoof. I'm a partner at Microsoft and Group Program Manager for Azure IoT. So what is Microsoft doing at the real estate event? Well, first of all, we are a big real estate portfolio manager and operator and owner ourselves. We have over 650 buildings across the globe as part of our campus settings, over 40 million square feet. And it turns out we're not the only ones with big portfolios like that, right? A lot of our big customers have facilities of any type and any kind And on this slide next to me, you see a lot of the blue rectangles that represent priority industries for Microsoft, where a lot of our big customers have operations. And you see the intersection there with the built world, right? The smart building in health and healthcare can be a hospital, a health and life sciences lab, an elder care facility. In retail, we see connected stores now, but also warehouses, distribution centers, and even a manufacturing plant is enveloped by a building, by a building enclosure with HVAC lighting, etc. And so an interesting trend is that what we see at the bottom, this evolution from intelligent assets, really where we've seen all kinds of assets from the physical world now getting connected. They used to be just that, physical assets, and now we can get signal from them by adding sensors or devices to them. And it gets us into the world where we can do remote monitoring, anomaly detection, throw some machine learning into the mix, and you can start to do high value add scenarios like predictive maintenance. And that in and of itself has been very transformative. But as we look at this bigger picture, you see this evolution into intelligent environments, and smart buildings are certainly very much a part of that, right? Where it's not just about the individual asset, but how they operate as part of a bigger and intelligent environment, and how that signal from the physical world really pushes us to the next level in modeling those environments, and then not just getting insights, but also start looking at modeling the behaviors of the activities that take place within those environments. And then you see the further push into the further interconnectivity. All of this is very transformative in and of itself. We talk a lot about the digital feedback loop and how we can get data of all aspects of an operation reconciled, and then derive the insights and the action out of that. But now, we want to push even further into this interconnectedness, right? I mentioned retail, for instance, and the stores and the distribution centers and warehouses is an example where you start to then drift into logistics, supply chain. On the picture, you see the cars and the connected fleets, the ways of transportation, smart rail, Maersk shipping containers, all the way to where the goods are manufactured in that manufacturing plant, which again is enveloped by a building enclosure. So all these things want to naturally further interconnect with each other. So that's a very important core premise. And so MIT published a very cool article just a couple of months ago, and that highlighted that because of this trend, we really have to not get stuck in our myopic industry-centric views necessarily, but there is an ongoing mindset shift from that focus on industries to really looking at the fulfillment of customer needs, many of which transcend the traditional boundaries. It's a very important entry point. There are a lot of catalytic innovations that enable us to look at the possibilities across that spectrum a little bit differently. I'll walk you quickly through a couple of the buzzwords of the day, as they have evolved over the years. 10 years ago, that was cloud. People were very confused at the time. Now it's become a lot more clear to people what the value has become of these globally available unlimited compute resources. We often use geek terms like ubiquitous distributed compute. That's really what that means, right? It's a very democratizing motion. Everybody can take advantage of it. And I think the benefits of the cloud are very well understood at this point. IoT was in the same realm, right? We were early players in IoT at Microsoft, starting about 6 years ago. Internet of Things, similarly, a lot of people grappled with the term and what it really meant. But in the animation on top, you see kind of these little nuggets of data going back and forth now, where you can get data from those physical assets and connect them to the cloud. And then we started talking about edge and the intelligence you can offload from the cloud to IoT devices. Very important evolution. Data has gravity, number of reasons why you want to transact and process on the edge, different protocol adaptations, latency reasons, privacy and security reasons, etc. And now you see loads like AI come into the mix. A lot of us look at real-time computer vision and audio. unique privacy concerns there that are very important to consider. Processing that data on the edge becomes a close tie-in between some of those aspects. And now you see that ongoing evolution all the way into digital twins, right? Where we can now model this whole physical environment, take advantage of all these previous breakthrough technologies and create these living replicas of any physical environment, make a rich model out of it, a graph representation, understand the relationships between all of these entities, which then allows us to track the past and predict the future. And you start to hear now more about the metaverse as another further push into this. All of this to say that these are actually real important undercurrents for everybody to pay attention to. But at the end of the day, end customers always look for solutions that do real things for them. And these are enabling technologies. Again, as solution builders, we need to be aware of them and take advantage for optimal use. But we shouldn't confuse people too much. Typically, over time, the value of these breakthrough catalytic innovations become clear over time. And we shouldn't bombard people with just the jargon, but really pay attention to what these breakthroughs can enable. So coming back to the smart buildings and facilities that we started with, these are just some examples in each of these categories. I mentioned priority industry verticals. Obviously, data centers are a unique activity domain for Microsoft as well. But the core aspect is that facilities are everywhere. Any of our big customers has to deal with them. And this goes through a variety translated into not just smart building, but making it very concrete in the context of the activity domain of the end customer. And it ranges from ports to plants and factories to stores and warehouses, all the way into brooder houses in greenhouses in agriculture, to healthcare hospitals and education settings and university campuses, etc. So it really can mean very different things in different contexts, but the built world is everywhere. So we have to pay attention. We feel, given what we do as a company, look at productivity from all aspects, real estate and the facilities are a very important component of that. One thing everybody attending this conference is familiar with is this kind of whole evolution from the whole ecosystem playing, starting with design, architecture, engineering, construction, a big chasm there, often now where data either gets lost entirely or tossed over the wall with a bunch of imprecision or paper or CD still, into commissioning a building, operating and maintaining it for a long duration of time, right? So there is many aspects of crossing the chasm here. Here's on the data estate. At each of these stages, data can get lost, and how can we do better in that regard? There's crossing the valuation creation chasm, right? So now we see, if you look at a building and from a building owner perspective, but also the tenant perspective, a lot of things being attached to the physical world. And, traditionally there used to be a bunch of them that are well understood. A building management system has been part of commercial real estate for quite some time. You have essential systems in there, fire alarm, security. You're going to have elevators for any type of high rise or elevation, interior lighting, etc. Those are kind of, sunk costs. You got to have them. You can't do without them. And now there's a growing array of additional pieces of equipment and physical assets that come into the mix, all of which get more and more instrumented, right? It can be soap and napkin dispensers from our friends at Kimberly-Clark or Essity or Gojo, appliances that can be hooked up now, people counting and occupancy tracking, all kinds of things, smart parking solutions, EV charging coming into the mix, and on and on. So it's a vast explosion of more and more systems that get connected. And so, all of them do something useful, but there is a challenge as a landlord on how much you can afford to invest in it, right? You tend to look at it through the lens of a base lease cost, your cost per square foot. and how much of this can I afford before my building may be non-competitive. So there is an element here of how can I decompose these islands, rebundle them into better understood value bundles. Some of our friends in real estate property owners call it placemaking. But there's things around, these are just artificially created, but getting around efficiently means everything from mobility, parking, public transportation, arriving and departure, a lobby experience within a building. How do I wayfind within my building, find my right location, schedule meetings, find my meeting rooms, etc. All the way into health and wellness aspects that have gotten a lot more attention during the pandemic. Sustainability, a big topic, topics like grid interactive efficient buildings, etc. The key thing is that some of these, when bundled correctly, can generate new revenue opportunities into these new placemaking service bundles. So that's another kind of crossing the chasm that we need to collectively achieve. And then there's obviously the technical integration challenge, right? A lot of these OT systems and IoT systems on the left-hand side of this wheel, a growing set of them, vast complexity coming into the mix, and more of them are available. As we work with a lot of big partners in the space, we've now indexed over 50 categories in that realm, and hundreds of vendors that can come into play. And how do I connect the data coming off of those systems to opportunities on the right-hand side of this wheel, my IT capabilities, the Microsoft Cloud at large, Microsoft 365, Dynamics 365, the full power of Azure, but also leveraging things like the Power Platform so I can connect to other existing line of business solutions and systems, either from Oracle, SAP, Salesforce, etc. So there's a massive integration challenge. A lot of these systems on the left-hand side now are intelligent systems. They come with a SaaS attached a lot of times, which is great because they're a lot more sophisticated and capable than they used to be. But now it's a matter of, hey, all these SaaS offers live in the subscription of a vendor. They have APIs, integrating that can be bespoke and custom. I need system integration dollars to do that. And the end result may still be quite fragile at the end of the day. So this clearly is an area that needs a lot of attention to make this whole wheel work as a wheel, well integrated and rolling smoothly. So this is where digital twins do come into the mix, and core assets like our platform as a service component called Azure Digital Twins, and the digital twin definition language. So ultimately, to connect these systems, we see that as a very important integration layer where I can do that modeling that we talked about at the beginning of the presentation. Build my model of the entire environment, then see where these assets fit into that broader model. And then I can make connection to specific spot solutions, right? In an office environment, that may be a lot of Microsoft 365, but even in other settings, like there's teams for healthcare, teams for retail. So all of those components are relevant. Microsoft Workplace Analytics and Microsoft Viva come into the mix. And then in other settings, you may bring in Microsoft Dynamics. And then through the Power Apps infrastructure, you can connect to not only players like Salesforce, SAP, Oracle, etc., for your general CRM, ERP, HR management solutions you may have in your environment, but also connect to very real estate specific solutions, whether it be Yardi or VTS or Angus systems, and do that in a way that can be done through Power App connectors as well. And so then we want to go a step further, right? To be able to make these connectors on the left-hand side fit into that same paradigm that we've applied on the IT world around the Power Platform, and make these connectors that can be low code, no code, to do the same for these OT, IoT type of solutions, which have very unique requirements around high volume telemetry streaming, as well as command and control going back to the other side. And to create that kind of abstraction, you really need standardization around the model. And this is where RealEstateCore became a key focus area for us. And that wasn't by happenstance. I'll talk more about that in a second. And working with Idun and PropTech OS as a specific example of real-world implementation, taking full advantage of that. And basically creating more of a loose coupling between the variety of systems on the left-hand side that can be plugged into a system like PropTech OS and a number of other Microsoft partners that take advantage of that platform as a service component called Azure Digital Twins. So this is an important core concept. Coming to these ontologies, concepts like Azure Digital Twins, the ability to graph a whole model, build the relationships between all of these entities, ingest live data from IoT as well as your LOB systems into that mix, propagate events and calculate it in the context of that graph, all very necessary and essential, but not sufficient, right? You need that standardized model. And so our approach to all of this at Microsoft has been to not reinvent the wheel, right? Digital twins are not a new concept, nor are ontologies. A lot of smart people, especially in academia, have been looking at this for a long time. And there are very well-established other schemas, like in this case, Project HStack, the brick schema, and IFC, obviously in the BIM space, the bot environment, etc. So we looked at all of them and for a wide variety of reasons landed on RealEstateCore as something we felt was holistically covering the spectrum really well. And where also we thought, because it's all open source, that we could establish an expressed version of that in the digital twin definition language, all in an open space, and then work with the core players, adapt, joining the RealEstateCore Consortium as Microsoft, working with other partners to rapidly continue to enhance and improve on it. And that's gone really well, right? So then we validate always at our own campus footprint as a big playground for us, deploy at large customer sites. We have fascinating, cool customer stories, both with Idun and Vasa Cronin, as well as with Willow and Brookfield, showing how this works in a real world setting at scale. And then obviously evangelize this, right? Make noise about this, make sure there's developer tooling around this. We're also a founding member of the Digital Twin Consortium, where we have an important forum to continue to drive this kind of narrative as well, which we're doing with all of our friends in the space. So very important, took off really well, published a blog when we first came out with it. It's one of the most read blogs in the history of the tech community blog at Microsoft at this point, and continues to get a lot of visitors, and obviously with an important and well visited GitHub repo as well. And as we build these kind of B2B connectors, these low code environments to connect additional systems into this mix, we also further continue to enrich and enhance the RealEstateCore ontology, very important. So that brings us back to that world where we said, hey, even if you start early, which is not always the case, but when you can start early at that design architecture phase, how you can now create this continuum with this kind of environment and have no data loss across the whole spectrum, right? The digital twin can hold all of this data, become ever more sophisticated to then have this full wheel in full action as you operate and maintain the building and have all the gory details of all the assets. Equally applicable to brownfield, however, and so that's an important topic as well on how do you bring all of that together. So here's some of the industry challenges related to that and where we as Microsoft are very focused to continue to address those as well. Obviously, sustainability, a huge topic. We just announced the public preview availability of the Cloud for Sustainability. Very important push for us. Obviously, Microsoft has been leaning in on sustainability heavily for several years now, and made some pretty significant commitments in that regard as well. But we all know in the US, the numbers are clear, right? The buildings consume 76% of electricity. and are responsible for more than 33% of emissions, worse than the rest of the world. And so we also believe that once you have, not only believe, we're proving that once you have something like a digital twin instantiation with this rich model, that we can now apply new techniques, cutting edge AI techniques like deep reinforcement learning, to really start to progress on concepts like grid interactive efficient buildings, right? Not just look at the building in isolation in the bubble of itself, but look at real-time signal coming off the grid, how the building interacts with the grid, and start to have these reinforcement learning techniques applied to that. And we're seeing some very, very significant breakthroughs when it comes to reducing electricity consumption and also reducing the greenhouse gas emissions. On the flip side of that coin, cybersecurity is a big topic as well, for OT and IoT systems, overlooked for many years. We're very active there now. We have Azure Defender for IoT. We just published a very cool story with end customer Ruden in the real estate space specifically. So if you haven't seen that, very easy to look for around Microsoft customer stories and Azure Defender for IoT, or just look for Ruden and you'll find a great story here on how you safeguard not just people, but the places and things within those places as well. And then the ever so sophisticated acceleration of facility onboarding. When you're in the space, you know that onboarding an on-premise system into a complex cloud solution, the BMS and the backnet infrastructure are not always that trivial to get onboarded, right? You typically go through a normalization phase for these more advanced scenarios, and that can take quite a bit of time. And you're going to need a bunch of your most experienced mechanical engineers, etc., go look at older drawings to reconcile some of the things that need to be cleaned up. It can take 2 to 3 months to onboard a brownfield building or brownfield setting. And this is also a perfect area where we're seeing very good results with machine learning based approach to semi-automate this process and bring it down from months to days. And that's something we've been doing on campus and with some bigger customers, so we'll continue to invest in this. And then the last part is connecting back to the first column here, the real-time ESG reporting. Obviously, ESG is getting a lot of attention. In general, I would say we're at a very interesting inflection point in history where you have these catalytic breakthroughs. On the technology side, you have a lot of experimentation with new business models, which is also related to that value creation slide, creating net operating income breakthroughs, lowering your CapEx spend, lowering your COGS as well. And then thirdly, you have all the policy and regulatory frameworks really pushing hard. And what we're seeing here is an opportunity to not see the last part as just all stick, but turn the holistic whole into a great carrot and stick operation. And so there will be an ongoing push around ESG regulation, a lot of discussion around greenwashing and how people make investments based on claims that companies make. So we can fully expect further scrutiny in that regard. And obviously with players like Idun and Witek, kind of front runners on the sustainability side, and GRESB ratings and investments in LEED. We think we can do a lot there as well to build systems that not only give you data and insights, but a push towards autonomous systems that can auto-resolve issues, get you the results you need, and facilitate the reporting into these kind of frameworks as well. So that's a critical area for us to help companies in the space not only measure, understand, but very importantly, take measurable action while managing all these aspects: energy consumption, reducing carbon emissions, the cybersecurity risks and the governance aspects around that, and ESG compliance in general. So I mentioned grid interactive efficient buildings. This is a big push. The Department of Energy here in the US has published a pretty hefty paper around it. The second one, this is a big topic. As I already mentioned, the core concept around this is to not just look at efficiency of the building in isolation, but start to look at what's happening on the left-hand side in the broader market around the energy space, all the way from generation, the wholesale markets, and the distribution utilities. Being aware of sustainability, the sustainability ecosystem, the impact there, understanding real-time pricing that you can get to your building, but also source of energy, source of origin of the energy coming to your building, and how you can use a lot of the things now showing up in your building, many of those on the left-hand side of the bigger wheel we showed, but some very concrete examples here connected to the building. And we see a number of click stops on how we evolve this, right? So as we facilitate onboarding of the BMS and the backnet infrastructure, there's a whole bunch of intelligent load management that we can do, create efficiencies, shedding load, low-hanging fruit that can be done there, certainly using some of these new AI techniques as well. As we bring in things like behind-the-meter storage, what we can start to do significantly further enhances, right? We're also with EV charging and EV infrastructure, concepts like EV to home, EV to grid. We can do a lot there as well around optimized storage and contribution, and starting to shift load intelligently as well, take advantage of a solar microgrid in a campus setting, or even on individual homes, and then all the way into that push into autonomous systems, bringing in that full power of the wheel, integrated into a digital twin, using a core ontology framework like RealEstateCore to now go full force in efficiency, shedding load, shifting load, modulating load, full awareness of the demands and the needs for the grid as well. And where you see in the US now, where the Federal Energy and Regulatory Commission has also pushed out Order 2222, as it's known, a long, complex topic around DER aggregation, distributed energy resources. But important there is that buildings, both commercial and residential, can play a very key role in that, and how you can start to operate them as a big, almost virtual battery in themselves that can aggregate as a virtual power plant. And numbers vary, but the numbers quoted by Neil Chatterjee, then chairman of the FERC when the order came out a little over a year ago, was 387 gigawatts based on the Wood Mackenzie report. And a significant part of that is the potential of the grid interactive efficient buildings showing up in these kind of settings. It's a very important concept there as well. And last, and I'll end on this note with this quick whirlwind tour and overview, but smart buildings make more productive people, right? We all know the numbers that JLL famously coined around the 330-300, the amount of energy you consume expressed in dollars, close in euros, I'm sure. Around energy at the bottom, $3, $30 around your leased and owned space, and then $300 around the people and the productivity of people. And so at all of these layers, a digital twin can inject all kinds of new capabilities. As you look at core energy management, sustainability, efficiencies around building operations and predictive maintenance, all the way into active measurement and management of space utilization, smart and intelligent parking solutions, things like frictionless access. All of those start to contribute to productivity of individuals as well and groups at large. And then ultimately, the whole notion of full-on ambient intelligence, right, where you bring in wayfinding and navigation, augmented mixed reality into the mix, how we optimize meetings, and very important topics like hybrid work, which is now fully acknowledged to not go away, and how do you not fly blind when you enter those kind of activity domains. All right, it's going to be very important to have that rich kind of setting, full wheel context to know what the impact is of new experiments you run. In some of these cases, when it comes to sustainability or hybrid, there'll be unknowns and people will need to run experiments, but then have the ability to measure and the autonomous systems that can take action by themselves. So I'll end on that note. I know this was a quick whirlwind tour, but this is why we're excited to work with the RealEstateCore Consortium, with partners like Idun and the PropTech OS. There's a lot here, a lot happening. People will be surprised what can happen in a very short period of time. We're all in, we're committed. This is an important space for Microsoft. I appreciate you having us here at this event, and I'm sure we'll interact with many of you who attended, as this is an important activity domain that will see a lot of progression over the next few months, years, for sure. Thanks again. My name is Bert van Hoof at Microsoft, and was thrilled to be here presenting to you at RECcon21.
Great. Fascinating presentation there from Bert, and we really appreciate him taking the time today to present to us. Yeah, I think, guys, one of the things that really stood out to me in that presentation was his slide on the data chasm, right? Something that we've certainly written about, right? This concept of where we are in construction, where with the design and build phase and the operate and maintain phase, having in between this kind of like black hole where data just gets sucked in and never comes out again. So, I mean, with you, Erik, I mean, how do you see RealEstateCore fitting into that and helping to solve that problem?
Yes, that's. I think one of the things that we have done together we have a couple of construction companies and RealEstateCore as members, and also we have these engineering consultants companies. Is that together with them and with property owners, we have made these construction requirements or design requirements. So already when it's being designed, the data is not being delivered in any format. It's actually being streamlined or being adapted to RealEstateCore. And I think that is a huge data saver, that you will get this data. And it doesn't cost anything extra. I mean, it's just stating that you have to structure your data, your tagging, whatever, in this way. It's really not an extra burden to the project. So I think that is one of the biggest things that we can help to salvage the data, so you don't have to redo it to enormous costs and with quality loss when you're redoing it.
Mm-hmm. Karl, anything to add?
Yeah, I mean, I recognize this gap that Bert speaks of and that you guys speak of. It is well known, and we have academics studying this type of problem, not only from a computer science and semantics point of view, but also from construction engineering departments at universities and so forth, and the whole BIM area. So if you look at the linked building data community group that I mentioned earlier, you'll see that you have representation of all of these, and they're intricately familiar with this problem space and this gap that exists. I think we could also say that there's also a gap between operation, not only construction and operation, but also between operation and renovation, or operation and eventually when you tear the building down. You know, there's in all of these sort of the operation stands out from the rest of the physical life cycle of the building. So there's definitely work to be done here. RealEstateCore is solving part of the problem, as Erik alludes to, but there's also more to be done for sure.
No, absolutely. You know, that's part of the issue, I think, with a lot of our domain, right? Is these silos of information and not just data, but working practices and procedures as well. Yeah. So I think if we can at least get people to talk the same data language, right, that will solve some of the issues at least. I think the other bit that stood out for me, of course, is Microsoft as a big tech company, that they said in the presentation he selected RealEstateCore. I mean, Erik, why do you think that was and is?
Yeah, I think it is because RealEstateCore has this business perspective, and also this agnosticism to other standards, that not trying to replace them, but rather to bridge and work and live with them together. And also that it actually has been developed not as a pure vendor or just one part of interest or a pure academic. It has been delivered. It has been developed together, and it has been developed together with several actors actually implementing it. So I mean, it's tested. It's. I think we're usually saying, Karl, that running code, when we're deciding on what should be implemented in the RealEstateCore in upcoming versions, that running code is very, very heavy.
Yeah, absolutely. I mean, it's as they say when they develop internet standards, rough consensus and running code over far-fetched or long-running, modeling perfection problems. Yeah.
Mm-hmm. Great. Mm-hmm. Okay, so let's get on with the next presentation. Getting started with RealEstateCore, and this is going to be presented by Karl, who is head of department of computing at Jönköping University. So yes, Karl heads the department for computing there and is the co-creator of the RealEstateCore ontology. His research focuses on methods for developing, managing, and deploying ontologies and other semantic technologies for data integration in different domains, in particular in the smart buildings field. So over to you, Karl.
So, hi. In this session, I'll be covering a little bit about the technical underpinnings of RealEstateCore, and I'll be discussing linked open data and ontologies and the RealEstateCore API, and how you might get started with actually building a system that speaks RealEstateCore. And before we can get into the details, I'm going to bring up some background because we come from the RealEstateCore work emanates in part from work on the semantic web. So I'm going to bring up a definition here about the semantic web, which is a work that academics and practitioners have been working on for, 20 years now. And the idea of the semantic web is to make information on the web, and in IT systems in the broader sense also, more well-defined, to provide a shared semantics and a shared syntax so that systems can interoperate and exchange data with one another, and thereby provide a wealth of features and functionalities. And this comes from the W3C and the founder of the World Wide Web, Tim Berners-Lee. And how would one go about this? I mentioned a couple of terms already. To begin with, we're going to have shared data formats if we want to exchange data. And you've heard of things like XML and JSON, and something called RDF is what we're typically using when we're dealing with semantic web data. And the format could be said to be your alphabet, in a sense, the way that you share data with one another, regardless of what kind of data that is. But that's not enough if you want to build intelligent systems and exchange information. You also need to have some shared definitions. And here you may have heard of things like JSON schema or Dublin core or SCOS, or these RDFS and OWL things, which RealEstateCore builds on. And the analogy here is that if you have a shared alphabet in the form of shared formats, your definitions will provide the dictionary of the kind of things you want to be able to talk about and the data that you want to be able to exchange. So, in order to have this semantic web and in order to have this exchangeability of data, what other requirements do we have aside from a shared format and a shared set of definitions? Well, for one, on the web and in systems nowadays in general, data is typically distributed across multiple nodes. So it's rare to have everything in your one bucket. And we also need our data to be uniquely identifiable. We need to be able to assign an ID to things like a room or a sensor or something, which we can uniquely identify that point by across this network of systems. We also need data to be easily retrievable using some sort of standardized method. And we need to express the data using a formal language, and that goes back to what I spoke of before, the semantics and the syntax. And ideally, we want to use what existing infrastructure and technology that we already have instead of reinventing the wheel. So those are some requirements in order to achieve, or in order to publish and achieve this semantic web of the future. And one proposed solution to this then is, I've mentioned RDF, the Resource Description Framework. It's a modeling language for how to express data on this semantic web. And there's a couple of principles for how you could publish linked data, as we call it, using RDF. So for one thing, we use URIs, that is to say web links, as identifiers. And that's very powerful because you usually think of web links as something you put in your web browser. But if you think about what it actually is with the domain name system and addresses beneath each domain, you actually already there have a globally unique namespace, right? In which you can carve out a piece and say, this is where I put my resources. So that's a very powerful mechanism, not just for fetching web content, but for actually naming things as well. And then ideally you want to use HTTP URIs, so Hypertext Transfer Protocol, which is an established standard for fetching content, typically web pages, but I mean, we can fetch other things with that as well. When someone looks up a web link, when they fetch that web link, we want to provide to them information using some formal representation, some standardized formal representation. That would be, again, the shared semantics that RealEstateCore is, and the shared syntax that you get by using something like RDF. And then we also want to link out and interlink to other systems and other resources so people can grow their knowledge graph step by step and learn more about the web. And while this started as sort of an academic and or researcher type challenge to work on these things, these days people are publishing a whole lot of data using linked data technologies and RDF. And this is just a small subset. If you go to lodcloud.net, you can read all about these different resources which are interlinked on the semantic web. So now that we have all of this linked data, how do we actually define the meaning of that data? How do we define the shared semantics that I spoke of before? Well, for this, we use what we call an ontology. Now, here is an academic definition of ontology, a formal, explicit specification of a shared conceptualization. And I'm just going to disentangle that a little bit for you. A conceptualization means that this is a data model that we're speaking of. So we conceptualize when we think of the generic rather than the specific. So instead of talking of the room that I'm presently in, we talk of rooms in the general sense. That's what conceptualization is. Shared conceptualization implies that this is something that multiple parties have agreed on and think is reasonable, so that we can exchange information with one another. Formal and explicit means basically that this is machine interpretable, that a machine can read and understand and do something with this, unlike, for instance, a whiteboard prototyping or a UML diagram, or a Word document for that matter. So going back then to what we spoke of before with the shared formats, if we have our linked data expressed using RDF as the shared format, the alphabet, if you will, of our data exchange, then we use the ontology as the dictionary describing the domain concepts that we want to work with, such that we can share it between one another. So that's using the OWL language, the web ontology language. We define our semantic web ontology to describe the concepts of the domain. If we want to get a little bit less academic and talk about it more plainly, we can think of ontologies as schemas for the linked data graph. So they include the types of things that we deal with, so the classes or the concepts of things that we deal with, the relations that can hold between those types of things, the data attributes that we can tag individual nodes in the graph with to give them some data, and any restrictions on the above that may be applicable. So essentially it's a set of reserved URIs in the graph that have a specific meaning. So in the example on the screen here, which is a graph of people that I know, a subset of the people I know, we have that Karl knows Eva. And Knows here is from the FOF ontology, friend of a friend ontology. And that specifically means that I know Eva. This means that not that we work together or that we've met at a conference once or something, but just knows. And everyone can use that IRI to denote what knows is in the common sense of the word. We also have, I've tagged myself with some data here. I have my full name here, and I have a school homepage for myself. And these are also taken from the FOF ontology. These URIs, that have specific meaning for this linked data graph, defining the semantics of the linked data graph. So RealEstateCore is an ontology that contains this kind of definitions, but for the real estate and smart building sector. And now we're going to take a look at RealEstateCore. This is the 10,000 meter overview of RealEstateCore using the web vowel visualizer, and it is kind of large. We are looking at about 837 classes or concepts, 151 object properties or relations, 292 data properties, or you could say data attributes. And that's much too large for me to cover everything in detail here, of course. So I'm going to give you an abstracted view and show the most important bits. And for each of these boxes, there are actually in the full ontology sub-boxes that give more detail, or for at least for many of them. So on the left-hand side, we have spaces and the building components. And this essentially covers the spatial topology and structure of the physical building. So we have things like building and land and levels within the building and rooms and sub-buildings and zones, which are all types of spaces. And spaces can be part of other spaces. So you can nest these things like Russian dolls, if you will. And spaces can be associated with building components. That's the physical structure that make up the building, like facades or balconies or slabs or roofs or what have you. And spaces can have geometry assigned to them using the GeoSparkle geometry vocabulary. So that's how we describe the building's spatial structure. On the top here, the red and the orange boxes, we have administrative functionalities. Agents being people or organizations that operate within the building. Could be tenants, or could be a facility management company, or could be the architect that originally designed the building, or their company. So these are the cognitive agents or human agents or organizations that operate within the building. Collections are administrative groupings of things that make sense to group. So things like a university campus, which would be a collection of buildings, or an apartment, which would be a collection of rooms, or a collection of assets in some system. So these make administrative sense to group together, though they might not necessarily have a spatial relationship with one another. Sometimes they do, sometimes they don't. The green box is assets. So these are things which are within the building, but which aren't part of the building structure itself. And this can be things like furniture, can be things like architectural assets that you move in and out of the building if needed, so not bolted down or not permanent. Can be equipment that is within the system, such as HVAC systems or fire alarm systems or networking or electricity and so forth. And this goes way much deeper in the real ontology than on this abstracted view. We have tons of data structure on that. And then the bottom orange capabilities describes how the building, how you can interoperate with the building. Sensors within the building that can detect things, actuators that can do things in the building, opening of locks or shutting of valves or what have you. And you'll note that the assets and the spaces can have these capabilities associated with them. So we can say that a room can report a temperature of a certain degree of centigrade or Fahrenheit. Or we could say that an equipment asset could report some pressure value, or could be run by or configured by an actuator that opens or closes some valve in some system. So these are the core functionalities that we try to cover. So administration, sensing and actuating, spatial topology, assets, and systems. But then there's a whole bunch of other things also. So before covering how you can yourself build systems using RealEstateCore and exchange data with such systems, I'm going to go through some of the guiding principles that we've followed when developing the RealEstateCore ontology. And the first principle here is that we want to reuse existing practices and technologies as far as possible and avoid reinventing the wheel. There are many ontologies out there which are really high quality and which are built for topics that relate to or border what we are looking for, and we want to reuse those as far as licensing terms allow, for two reasons. One is that it saves us effort, of course, and that we don't have to create things from scratch. And the other is that in the future we may want to exchange data with someone using that model, and then it makes sense if we're reasonably compliant with their worldview. It makes things a lot easier. The other guiding principle is that we try to keep the use cases at top of mind at all times, and we try to solve practical problems that our developers have. Sometimes you'll come across ontologies which are sort of ontologies that are driven by a modeling ambition as opposed to a practical ambition. And we try to avoid that as far as possible. We very firmly fall on the applied side of that fence. And from this follows that we go sufficiently deep in modeling the things that we model. We don't go in depth in modeling all sorts of things. So if you want to have a system which is, an in-depth control loop, control system for an HVAC system, that's probably not best modeled using RealEstateCore. Our use cases are what brings value to the real estate owners and the people operating within the building on the higher abstraction level. And since we have this back and forth with our developers, we have this development loop, deploy, argue with one another, modify, redeploy, to try to figure out and fix as we proceed. So while older models or older versions of the model are stable and are available in perpetuity, ideally, what the current development branch can be under flux at any time. And it is sort of combat proven by deployments in systems using, among some of the partners present here today. And of course, it's important for us to use open licensing, an open and accessible community process through GitHub, and to have an open mind when we come across solutions that others have that are better than our own. Right? So, moving forward then to the building of systems. I said earlier that we need two levels of interoperability. We need shared formats, and we need shared definitions. And the question is this really enough to actually build an ecosystem where you can exchange data between systems? And we very firmly say, no, it is not enough. It's required, but it's not enough. We also need data ingestion methods to talk to the legacy systems that are in the existing building portfolios of every company. We need API definitions to help us exchange data using these fancy semantics that we developed. We need software libraries to parse and operate on this data and do something useful with it to simplify the deployment of systems for our developer users. And we need best practice recommendations on how you yourself can build systems and talk to systems that use RealEstateCore. So the ontology is not enough. And ideally, we want all of these things also to have open source reference implementations that you can just download and play around with and run. So what I'm going to start by talking about is the APIs that we developed to start filling these gaps. And if you go to our GitHub repository, there's actually an API subdirectory in which you will find documentation on the RESTful APIs that we've developed and the API specification itself, and also the edge message schema. Now, the RESTful API definition is a Swagger definition, and you can open it in the Swagger editor and you can download it from there, from the GitHub repository. And the design is basically that we've taken a reasonable subset of the classes that we have in RealEstateCore, and then we provide, using HTTP verbs, the standard create, read, update, delete operations across those types. So this is where you would create your building graph, which is consistent with your RealEstateCore ontology. And this API is actually generated automatically through a translation process from the ontology. So when we release a new ontology, what we do is we tag up the classes that we think are reasonable to include in the API definition, and then we run our translator tool and it generates the API definition automatically. The payload schemas that we accept for put and patch and get and post and all this are JSON LD based. JSON LD is an extension to the common JSON schema or JSON format, which adds a little bit of context, and that context is required to give a globally addressable namespace for the messages. So what JSON LD is actually, in fact, is a JSON representation of an RDF graph. So we're sending RDF, it looks like JSON to your developers, they just add a little bit of extra tag at the top to give the context required to actually create the RDF structure. So you can reuse your existing development workflows and competencies. When we do collections of items and pagination across collections, we use something called the Hydra vocabulary, and it's fairly straightforward. So no surprise there. And for filtering of queries and the sorting of results and so forth, we use JSON API principles. And again, there's nothing rocket science about that. It's fairly established. So this API then allows you to build clients that operate on top of a system that expresses data using RealEstateCore, using techniques that would be familiar to most web developers. We also have the edge message schema, which is for talking to the building systems themselves. So not talking to client software, but talking to the, where we get the data from. And here we're typically constrained a little bit by bandwidth or power requirements or so forth. So this is aimed to be a bit more lightweight. This is a simplified JSON schema that allows you to send observations from the edge into the cloud, to order actuations to take place from the cloud to the edge, allows you to respond from what happened when you did that actuation, and also allows you to send exceptions. And this is a somewhat simplified representation that I'm showing here just to fit the slide. In the full version, of course, the device ID and the sensor ID and so forth would be full URIs, which are globally dereferenceable, again, because we use URIs for IDs. And this is all in the GitHub repository, so you can go in there and look at our API specifications. So, knowing all of this, how do we put this together to build a digital twin platform? Well, this is the general system architecture that we'd recommend. On the bottom edge, the southbound edge, if you will, you have your buildings. And there you have building management system that you talk to using the RealEstateCore Edge API, so the message format that I just showed you. On the top end, you have your RESTful API that talks to mobile clients or computer clients or some analytics software or something using RESTful queries. You could have dashboards as well. You could, if you wished to, use also streaming APIs that provide the data directly from the building. We haven't yet standardized that bit through RealEstateCore, but we have the RESTful API and we have the Edge API on the southbound edge. And then in between those two, you have some sort of data integration platform or a digital twin platform. And that platform would consist of at least two components. It would consist of your building graph describing your buildings and their internal structure and what's in them and how they operate. And it would consist of the current state of that building. So if the building graph would contain things like there are rooms which are on certain floors that are in certain wings of the building, and then the building state might be that the door to that particular room is currently locked or unlocked, or the temperature in that particular wing or a part of it is currently 33 degrees, or well, probably unreasonable, let's say 23 degrees. But what you'll note also here out on the left-hand side is Administrative System X and CAD System Y. It might contain information about your tenants or your CAD files about the building. Now, we don't foresee the RECcon21 ecosystem sort of describing every aspect of buildings and building management. There are good systems out there already and models out there for a variety of domains, and we think it makes more sense to try to align to those systems rather than attempt to replace them. So you would link out from nodes in your building graph to those other systems in order to, at query time, fetch the data that is needed to accomplish the task the user has. Now what RealEstateCore does is, again, where you have the RealEstateCore icon here, is it provides the API definitions, and that very neatly makes it possible to decouple your implementation from these systems. So you can change out your client, as long as it is RealEstateCore compatible, you can change out your mobile clients. Or you can tell your system developers or your consultants that this is the API spec that they target, and you can then easily reach a broader number of consultants that have that competency, are familiar with that API, and vice versa. Those consultants or developers could deploy their solutions for multiple clients. So it's a win-win here. We build an economic ecosystem around this standardization of APIs. We also, by having done the modeling already, we simplify the construction of the building graph. You don't need to think about what is the most reasonable way to organize a smart building, because we've done a bit of our homework on that end. So we get both a decoupling of services and clients and a simplified deployment of building systems. So how do we then practically build this digital twin platform, this purplish box in the middle here? We don't at the moment have an open source reference solution hosted by the RealEstateCore Consortium. We have played around with the idea, and we may do so in the future, but for now you're going to have to build that box or buy that box. And here are a couple of solutions for how you might do that. Most sort of semantic web native way of doing it would be to use a native RDF database, also known as a triple store. And that database would talk to some API backend, which would support these two APIs that we've spoken of, the RESTful and the Edge message API, using the Sparkle query language, which is like the SQL query language, except for RDF graphs. Now, an advantage to this approach is that if you're using a native RDF database or triple store, you have these features that are built in there that can be quite powerful, such as automatic retrieval of these URIs if they are distributed across the web. So you can actually fetch content automatically from such systems, from other systems on the web, without having to build that engine yourself. And you have things like OWL reasoning in case you want to do logic reasoning across your graph. You can do that with the features that are built into many of these triple stores. The Sparkle query layer needed to translate the APIs into the database can be comparatively shallow, comparatively simple mapping of REST API or Edge API to data structure within the database. So it's comparatively cheap to build and cheap to maintain. And there are open source options available for this type of technologies. So you, in the ideal case, need to pay very little. The disadvantage obviously here is that this is a new tool stack to a lot of developers. It's likely to require that you support your developers and have training for your developers to get on board with using RDF graphs natively. And if that is a problem or a challenge for you, another option might be to use a non-RDF database. Use something that you're already familiar with. So you still store your graphs in the database, but you could use something like Neo4j, or you could use a relational database or something that you already have competence in and tooling that you already invested time and money on. And you could align then to your existing data management strategies and simply provide a graph representation API on top of that. The disadvantage to this is that since there is no sort of IoT specific or digital twin specific feature set in most database engines now, and since there's no resource description framework, RDF graph feature set in most such databases, what you end up with is that this API backend box and DB query layer might become a lot thicker and therefore more expensive to develop and to maintain. But there are partners in the consortium who worked in this way and who've had some success with, for instance, Neo4j and the Neo-Semantics plugin, which allows you to bridge between Neo4j and RDF and OWL representations. So that's a very powerful mechanism. So you can certainly try that. And then we have the IoT-specific solution. And I should say here that while we have collaborated with Microsoft and with the Azure Digital Twins team, of course there are other vendors also on the market. But what we have is we have a collaboration such that the DTDL version of RealEstateCore is officially released by the Azure Smart Spaces and Energy team through the Azure GitHub organization. Now, DTDL is Microsoft's digital twin definition language. So what we're essentially doing is we are directly from RealEstateCore generating DTDL models through a translation mechanism, again. And this makes it very easy to bootstrap a digital twin, Azure Digital Twin solution using Azure components. Now, in the process of translating from RealEstateCore to DTDL version, there are some features that aren't included because they overlap between what's built in natively into the DTDL language. So some features are left out, but those are instead replaced by native features in the DTDL language. And what you might do then is you might use something like Azure Functions to host your APIs on the north and southbound edge. You might use the Azure IoT Hub and IoT Edge runtime to ingest data from your existing building portfolios. And you might then propagate data out into other Azure component systems, like your time series insights to do time series analysis, or your maps to do visualizations across maps. Of course, if you do choose to do that, then you are sort of increasing your dependence on the Azure technology stack rather than just being platform independent as RealEstateCore is natively. But so you'll as a developer and as a decision maker have to decide whether this is a trade-off you're willing to make. But if you're willing to make that, that would be one way going forward. And there are good and actually really good documentations available through the Microsoft Azure Digital Twins documentation site to help you figure out how to build that best. So thank you for listening. And in closing, I'd just like to say that if you would like to get involved with RealEstateCore, or if you would like to try out using RealEstateCore, we really would love if you got in touch. This is an open community process and we love growing the community. So ask us any questions, reach out via email or via chat channels or whatever way suits you. Thank you, and I hope you have a nice continued conference.
Karl, thank you very much. Very interesting presentation. So I have a question. I mean, I think if I was to put my building owner's hat on, right, and I'm listening to this, I might be interested in an example of how I might, go about creating my own digital twin platform. And therefore, about building this building graph, right, for my portfolio in RealEstateCore. So, I mean, is there some way I can translate, let's say if I had some CAD files or something automatically into RealEstateCore to get my building graph?
Yeah, so I'd say CAD files are a bit of a special example. I'd probably leave those CAD files in a system devoted to CAD files and link out, as I think I mentioned during the talk, from your digital twin representation in your building graph to that representation, so that the system could fetch CAD data as needed. But I don't think necessarily including the CAD files in the building graph is technically the best approach. But when it comes to other kinds of data, well, if you want to put them in the building graph, if you think it makes sense to keep them there and to manage them there within the building graph, yeah, you should by all means try to do so. And exactly how you go about that would depend on what of the solutions that I presented that you choose, what your database looks like, and what the APIs against that database is. I mean, could be anything from translation from CSV files into SQL or through to some graph language or to RDF triples if that's your preference, and loading via one of a multitude of APIs. And then you have, of course, the challenge then of getting that data out from your existing portfolio of buildings in a structured manner, because assuming you don't already have all of those really well-formatted CSV files and so forth, and that can be a challenge, particularly if you've accumulated your portfolio over time, and the tagging might not be entirely consistent and so forth. So I know that there are companies out there who apply machine learning techniques to try to categorize tags in BMS systems and so forth. And that's not my personal forte, but I've heard that's an approach that people use. I'm thinking, Erik, you probably have some experience in this, having worked with, Vasakronan and others.
Yeah, no, I think this is one of the biggest challenges. I mean, the technical depth that you have, as you said before, that you have different tagging standards, and they are usually made depending on what engineer it was that did it that day. So this is, and as you said, there are lots of different specialized companies that just do this kind of machine learning based tagging extraction and decoding of DVGs, AutoCAD files and similar. So I mean, when we have been working with this, when we began with this several years ago, it took 100 or even more than 100 hours to decode a building. But the tool sets are coming more and more, and we have lots of partners in the RealEstateCore community that have different tool sets for this, both from the BIM side and also from the BMS side.
Okay. So, again, if I said that there are building owners out there who are interested in this kind of thing, maybe they can reach out to some of the consortium members.
Yes.
And ask those kind of questions, right?
Yeah.
Okay. Great. Again, thanks very much, Karl.
Thank you.
So let's get on now with our fourth presentation. And this is called Using RealEstateCore for the Smartest Building in the World 2021. And this presentation is given by Anders Stenbäck, who's VP of Offering and Services at YIT. So a little bit of information about Anders. Anders Stenbäck is a senior digital change leader with a proven track record in turnaround of B2B and B2C digital businesses in the financial, media and retail industries. He's an exceptional senior leadership level network in online industry in the US and Nordics. Platform economy, digital marketing, new business development, AI data and analytics, startups cloud, and new business ventures as key competence areas. Take it away, Anders.
Hello everyone, and welcome to this section, which is entitled Using RealEstateCore for YIT's Smart Buildings. My name is Anders Stenbäck. I'm the Vice President of Offering and Services at YIT. Today I want to discuss with you about the following topics: about work-life in transition and about our research on millennials and what they expect from the future of offices. And then on our research and white papers in the area on 10 recommendations for employers and leaders. And then I want to move on to how we are using PropTech OS and RealEstateCore to build YIT's smart building concept here in Finland. So let's dive in. As we all know, the work life is in transition, and the pandemic has changed the way that we work permanently. And many of us are now thinking about how we should get back to the office, how much time we should spend remotely, how much in the office, and how to make all of this work. What can clearly be seen is that people don't want to go back to bad offices. And research globally shows that in, for example, this Leesman study of almost 75,000 people globally, that
2 to 3 days per week will probably be the norm for the coming years. So how do we ensure that work encounters and work communities are maintained? We asked millennials, and why so? Because they will soon make up half of the global workforce. So together with the next gen community, we set out to do a large survey of this younger population. So millennials aged or born 1981 to 96, and then Gen Z from 97 to 2012. And we interviewed around 1,100 participants in Finland, the Nordics, and the Baltics. And here are the results. The pandemic has caused many young people to give more to their work. A lot of people have felt that it has been quite difficult. And also what they see is that they need a lot of support when getting back to the office. Maybe the most important findings is that people want a sense of purpose and a sense of community, a reason larger than just working, but a reason why the company is contributing something to the world at large. According to our research, this young generation says that 2 days per week would be optimal at the office, 2 days remotely, and then interestingly 1 day per week in order to enhance your own well-being or the well-being of others through doing, for example, voluntary work or to work as an entrepreneur. So what do millennials want from the actual work environments? Well, the top 3 things were that they want to be able to work remotely whenever they want, and they want the trip from home to the workplace to take less than 15 minutes. And they quite surprisingly say that they want their own desk at work. I'll get back to that in a minute. So what's this 15-minute city? Well, it's something that we at YIT believe quite strongly in, a more sustainable built environment where people can thrive and easily get around the city, where there are an abundance of services close to where you live and where you work. So what does this mean then? Well, for many of us, it means that their own desk is something that the millennials actually asked for. And why is that? It is because they want kind of a sense of security, of permanence. When they do come back to the office, they want to feel that they actually are appreciated in the work environment. And is it a status symbol? We don't know, but it allows then for personalization and customization. And I think all in all, the big thing is that this generation, they really want to feel that they make a difference, that the company they work for, that they provide a sense of purpose. Quite interesting finding was also that this younger generation, they want to use a car, and also with more and more ecological and electrical cars being the stigma of owning a car is maybe not as strong after the pandemic. The personal space, the health and well-being of the individual has become more important. So returning to the head office or having the possibility to work in remote working hubs, 85% of respondents said that they don't have a preference of one office, but the working, so that the premises should support that the fact that not everyone works at the same office. It should provide a individuality and a sense of ownership for the people working there, and the premise it should communicate the values and the ethics of the company. Those were the things that came out of our interviews. So based on the research results, we compiled kind of 10 recommendations for employers. You can download these on our web pages, but it's about how to attract this next generation of talent, how to keep the talent, how to lead this young generation, and kind of what concrete work conditions are preferred by this next generation of talent. I'll provide a link at the end where you can download this research. Quite interesting things when you're building new offices, thinking about how to remodel old offices, and also how to implement the hybrid work at your own company. So moving on then to YIT's response to this. So we took all of this research and we looked at one of the old buildings in Helsinki. You see the picture here at the bottom left-hand side. So this used to be the old Telia headquarters in Helsinki. It was originally built in the 1930s and acted as a bakery. Back then in the 80s, it was converted into Telia's headquarters, and on the right you see what the building looks like today. So we took an old building which was not super modern and converted it using modern sensors, IoT technology, into something we're quite proud of. We recently received the Platinum level certification of the Smart Building Council, and also now won the award for the world's most intelligent building of 2021. So what is this building? Well, it's part of a network of co-working locations where we provide a new business model, which is office space as a service. We now operate 4 locations across the Helsinki metropolitan region, and the concept is heavily built on hotel class, abundant services. So things people have looked for and want when they come back to the office. So we have an app where you book your meeting room or your workspace or silent workspace for the day or for the hour. We provide mobility services. We have a professional recording studio and podcast rooms. We have different project rooms, event space, auditorium, and things that companies can use by the hour. And then we provide evening spaces, restaurants, cafes, and when you enter the building, you enter into the lounge area that converts into a after-work lounge during the evenings. So all of these are made to give a really smooth experience for your workday and also to support collaboration and chance encounters. So how are we using data and sensors? Well, here is one example. So this is based on the surveillance camera, so the CCTV system, and then we combine that with the signal strength from the wireless network in the building. And based on that, we can see which are the most popular areas during different times of the day. And this enables us to optimize the space, so we get insights on where people want, what type of amenities they want to use, what types of different rooms, which desks are the most popular, and then we can make more of those things that people actually like and want. All these data from the different sensors is brought back to PropTech OS. So that acts as the digital twin and the real-time model of the building. We use the same digital twin and the data in PropTech OS to then steer different use cases. One of them we built together with a PropTech company called Nuka, and Nuka Optimize helps to optimize the heating and cooling of the building. So based on the reservation data for the desks and the meeting rooms, we now know how many people and what time people will be in the building tomorrow. And then Nuka's AI technology then looks at the weather forecast, the reservation forecast, and then on the Nord Pool energy exchange electricity price for tomorrow, takes all of these variables and then either pre-cools or preheats the building so that the conditions are optimal for the following day while saving cost. With this, we typically save around 20% in our energy costs. The other part we use Nuka for is it integrates with the building automation system and then pulls the data into PropTech OS, where all the data from the different sensors are. And then it has built-in 170 different cases of faults, and through PropTech OS we automatically push fault indications to the facility management system Granlund Manager, and this way we can do predictive maintenance of the HVAC system. We can read off different energy meters, and all of this data is then displayed to the building owner as well to the facility manager through easy-to-use user interfaces. Some other use cases that we have implemented in this world's most intelligent building is on the top here. We use people counting sensors from UbiquiSense that tells us how many people are in the rooms. We use this to optimize the business model for how and what to charge for the usage of meeting rooms. On the right, we have data from the actual usage of different parts of the building. So we optimize our cleaning. So only those areas that have been used during that day are then cleaned, and this helps us save on cleaning costs. And here on the bottom, you see the predictive algorithm that is being used for the catering. So based on the usage of the building, the past usage, we can make a prediction about how many people, and the reservation data, how many people will be eating lunch tomorrow and then or next week, and this then enable the restaurant to plan and thus reduce waste in the catering. So on one hand, we have the standard YIT smart building productification, which is the BMS and the HVAC system, where we use Nuka, Haltian's presence sensors, UbiquiSense people counting, and then Ava security for the video surveillance, AI image recognition, and then Granlund for the facility management. All of this data we pull into PropTech OS that provides the digital twin and the real-time model of that. These different players in the ecosystem talk to one another using the RealEstateCore ontology, and that those standardized APIs then provided by RealEstateCore are then used for different end user interfaces. So we have our Workery Plus mobile app that can be freely downloaded in the app stores. We have different BI reports that are used for business optimization, and then we have different facility management operative user interfaces. So all in all, about 13 systems have been integrated into this smartest building in the world. We're now on the verge of launching our own developer APIs and hope to be able to do that for every new building that we are doing beginning of next year. So the benefits of using RealEstateCore for YIT is that enables us to use both the latest in IoT technology and sensors, and also combine that with legacy systems such as old building management systems, and all this to enable new innovative service for our users and owners. RealEstateCore also enables us to break the vendor lock and gives us the best way to access different ecosystems, so different vendors can work on the same platform and exchange data between themselves in real time. And therefore, we have decided that RealEstateCore is part of our planning guidelines, meaning all new property development that we will do will have as a requirement to the planning agencies doing the architectural, HVAC, electrical, and so on planning, that they need to standardize and use RealEstateCore to connect the different parts of the building and then provide an API on top. So all in all, quite happy and proud of what we have been able to achieve together with our Swedish colleagues, and really looking forward to how PropTech OS and RealEstateCore will develop going forward. As I said here, with intelligence and data, we at YIT are able to create more people-oriented, more flexible offices for a more sustainable built environment. You can read more about this and download our millennial research at yit.fi/en/next generation work. Thank you so much. Greetings from Helsinki, and I'm happy to answer more questions that you have.
Great, thanks, Anders. Another excellent presentation there. I think we just can tease out quite a lot from that presentation. It's great to see, of course, to see a company like YIT using RealEstateCore. And I mean, what kind of stood out for me is that it seems like they are really serious about using this as a foundation for their digital services going forward. I thought there was an interesting comment there then about them, or one of the reasons why they're using RealEstateCore is about breaking this vendor lock-in, right? That was certainly a point on one of his slides. Although, Erik, I mean, can you explain why you think that's so important to companies, and sort of how RealEstateCore helps in with that issue?
Yes, I think that you can see this is like a double-edged sword. I mean, when you are building on RealEstateCore, as we said before, RealEstateCore is not just an ontology, a data schema. It's also actually an API specifications. I mean, we are working to achieve portability. And this is the way that you actually can, as a property owner or a constructor, you can actually select which energy optimization program or application should I use, and choose the one that fits your needs best. And at the same time, if you are a provider, a vendor, it's quite easy. You integrate once, and then you can roll it out in a full portfolio. So I mean, it goes both ways. It enables. I think this is just a natural step. I mean, in so many other domains or business domains, you have this kind of standards. I mean, electrical plugs, app stores or Android app stores, whatever. You see this kind of portability, I think, and I think that is something that is being picked up, that you don't want to be locked in by it's too expensive to
exactly
change.
Yeah. Yeah, I mean, it's been quite a common problem, I think, for a lot of companies for a while. Yeah. Anything to add to that, Karl?
Yeah, I mean, that was a really, really cool building there, and he made some good points on what millennials want in the workplace going forward. And one thing which I thought of in relation to this is sort of when you, from a brand building point of view, when you want to attract, whether it be millennials or people leading the curve in various developments, you'd like to, I think, be sort of perceived as being on the leading edge of development. And I think there's something to be said here for smart buildings and interoperable and standardized smart buildings being an idea that is sort of in the zeitgeist, if you will. It's an idea that's about to be born fully. And that's a very, very powerful thing because it sort of sells itself. I mean, there are good business cases, obviously, very good business cases, as several speakers have alluded to, but it's also an obvious idea. If you talk to a software developer, and ask them, why shouldn't a building have an API? Of course, they're going to say, yeah, of course a building should have an API. Everything can have an API. So it's an idea that makes intuitive sense to developers to do this, and that essentially sells itself. And I think if that's the case, that's going to come true one way or another. So why not get on the train early and build your brand in being an active participant in this, using, for instance, RealEstateCore, right?
No, indeed. Yeah, great point. Okay, well, let's move on now with our fifth presentation. And this is called How RealEstateCore Enables Automation of Lead Certification. And this is going to be given by David Witek. David joined the US Green Building Council in 2006 and currently serves as the organization's Senior Vice President of Finance, Operations and Administration. He also serves as the executive lead for some of the newest rating systems to be added to the organization, Peer, Sites, ParkSmart and True. In this capacity, he manages their programmatic development, which extends the organization's reach into the energy sector, land development, parking, and zero waste. As head of operations, Dave is responsible for identifying improvements to existing processes, developing and implementing processes for new lines of business, and liaising with strategic partners. Okay, so over to you, David.
Good morning or good evening, depending on where you're dialing in from. My name is Dave Witek, and I'm the Chief Operating Officer for RealEstateCore. Thank you very much for the opportunity to speak with you today about ARC, as well as the importance of an integrated ecosystem to help us meet our sustainability goals. ARC is part of the USGBC and GBCI family, and as you may know, USGBC owns and maintains the LEED rating system. With over 110,000 projects across more than 180 countries and territories, LEED is the foremost green building rating system in the world. And GBCI is the credentialing organization and the reviewing body for LEED certification submissions. ARC is a technology platform which measures the real-world performance of your building or space. It picks up where LEED has traditionally left off. LEED has historically focused on the design and construction of your space, but ARC comes in once your building goes operational. It's intended to answer the question of whether your space is still performing like it was designed to, even if it's years later. We take your data, we run it through a LEED filter for energy, water, waste, transportation, and human experience, and we provide a performance score. With that performance score, you're able to compare yourself against other projects. Those could be prior versions of your own project, other buildings within your city or your country, or buildings from around the world. We've added more benchmarks for you to use, but I'll speak more about those in a few minutes. We also have the ability to analyze your performance and then communicate that through different forms and methods. We provide the flexibility for you to follow the pathway which fits best for you. We're the exclusive platform for pursuing LEED version 4.1 operations and maintenance certification and to recertify your project to LEED. But we realize that not everyone can achieve or wants to pursue LEED certification. You're still able to create your project, bring your data onto the ARC platform, and receive a performance score, even if you don't have LEED aspirations at the moment. I mentioned who and what ARC is and what we do, but why are we doing this? The green building industry is changing rapidly. This is driven by factors including new sources of capital, new mandates, and new performance expectations. These factors are reshaping everything that we do. Investors have begun to recognize opportunities to achieve market returns while providing significant social and environmental benefits. ESG-related debt issues in 2021 will approach $1 trillion. Deal sizes are steadily growing, and this provides new opportunities to drive market transformation over unprecedented scales and over significant periods of time. Green buildings and a range of green building related activities feature prominently in these new financial instruments. This is reflected in the use of proceeds, including $65 billion allocated to green buildings alone in 2021. Many of these investments are intended to support increasingly aggressive decarbonization pathways, such as the IEA's 2050 roadmap. This calls for a dramatic economy-wide emissions reduction, including near zero from the building sector by 2040. These aggressive allocations and goals are generating new concerns about real-world outcomes and, in turn, greenwashing. According to Google, searches for greenwashing have increased threefold since late 2019. This reflects the concern that investments being made aren't having the intended result. So, measurable improvements in performance are a must to provide these proven results. And these concerns that we're seeing around greenwashing are global, from US regulators suing companies over their efforts to European regulators investigating asset managers related to their practices, to climate activists paying closer attention to results and not just the policies. We believe that we can navigate these trends with three strategies: clear performance intentions, that means setting your goals and targets to align with climate and sustainability goals; real-world measured performance; and independent review and recognition. These strategies provide the foundation for what ARC is and what it does, and they represent the opportunity for partnerships that allow us to achieve more together than any of us can achieve on our own. So who uses ARC and why are they using it? To be glib, pretty much anybody can use ARC, but I'll refine that a little bit more for you. Investors are seeing the benefit of ARC for things like their GRESB and CDP submissions. They're able to use ARC to get what they need, like certifications, energy ratings, and carbon emissions, in order to score better. With the job market super tight, or at least it is here in the United States, owners and occupiers are becoming competitive on the environment that they provide for their employees. And the pandemic that we've been experiencing the last 20 months, we've all become experts in the importance of good indoor air quality. Through ARC, you're able to measure, track, and report on the critical factors like relative humidity, particulate matter, and carbon dioxide, which influence the air quality in your space. And the government is able to use ARC to look at source energy as we move toward a more electric world, and GHG emissions as an indicator of whether we're making progress. An example of someone who's come to ARC is this global portfolio. They have over 1,200 locations representing 100 million square feet. They wanted to determine what their consolidated global carbon footprint was. But as you can see this map, they're in over 100 countries. So everyone was using a different metric, a different calculation, and a different unit of measure. They brought their entire portfolio onto the ARC platform, and now they have one way of collecting the data, one calculation, and one unit of measurement. So now they can determine their global carbon footprint and begin to focus on the steps they need to take to reduce it. Our approach to help determine whether you're on the right path is through the introduction of additional benchmarks beyond just our own. There are about 60 established benchmarks in the US currently and a number internationally as well. These include straightforward approaches like have been created in Orlando, Florida and Seattle, Washington, to more complex approaches like Local Law 97 in New York City or Boston's BERTO benchmark. We've included global targets in ARC as well, including CREM and GRES. We've started with about a dozen benchmarks so far, but we plan to add many more over the next several months. To give you an idea of what this looks like, here's an example of CREM's 1.5 degree target for a commercial office space in Sweden. You can see the glide path that the project must achieve each year from 2021 through 2050 in order to reach its target. We measure your current performance based on data that you've already provided to us in ARC. And then we could tell you whether you're in compliance or not, what year you're in compliance until, and what % improvement you need to make in order to get into compliance. And we've created this CREM pathway for all countries in Europe to utilize. Another component in ARC that we've created to help you achieve your sustainability goals is our climate risk tool. This directly supports the task force on climate-related financial disclosures by providing responses around transition risk and physical risk. Our carbon score and electrification score help inform you of your progress towards a cleaner and greener economy. And we offer a physical risk report through a partnership with Moody's ESG Solutions. This informs you about risk levels for natural hazards such as sea level rise, flooding, and other hazards. For each address that you provide us, you'll receive a risk level rating, a site score, and a country-specific score. Also include our several subcategory scores as well. And your results can be viewed in either an Excel export or a PDF report for easy sharing. Now, we're just a convener and an interpreter of this data. We are partnering with many other organizations to give perspective to this data. I shared our work with Moody's on physical risk and with government agencies on energy and GHG ordinances. We have many other partners, including partners who use RealEstateCore to collect and aggregate the data that we use on our platform. The process of utilizing RealEstateCore to get to the LEED certification or just to track and benchmark your project is very straightforward. You start with the basics like goal setting, creating a certification schedule, and identifying your data collection sources. Then you install sensors and you connect them all to a RealEstateCore platform. Then you pair those buildings and sensors with the platform. This approach will let you move towards certification for an entire portfolio rather than a single building at a time approach. In this step, you document each process for how you handle your data. And by doing this and then getting the documentation validated, you can avoid this repetitive task for each individual building. A RealEstateCore platform provides all of the data to ARC, which helps you track, manage, score, and benchmark your performance. But it lets you also submit your data to GBCI for LEED certification. The end result, if all goes well, is you receive that third-party LEED certification recognition. Now, there is a sixth step that I haven't documented here. It's continuing to provide your data to ARC through a RealEstateCore platform, even after certification. This way, you work toward continuous performance improvement, compliance with ordinances, and are prepared to submit for recertification to LEED. The RealEstateCore has many benefits. The most important to you in your job would be saving money for your company through efficiencies, reducing errors by automating the processes, and removing manual work from your desk. And your organization will appreciate the ease of certifying a whole portfolio of buildings all at once, identifying compliance with ordinances, and being identified as a leader in the industry. Through the partnerships that we have with RealEstateCore, Moody's, and others, we will create an ecosystem that helps us reach the sustainability and GHG targets that we must achieve. Thank you very much for the time today and the opportunity to speak with you. Please, if you have any questions or want to learn more about ARC, visit arcscore.com.
Okay, thanks, David. That was another awesome presentation there. Yeah, and Erik, I don't know what you picked out of it, but certainly for me, like what came across there is, really some of these ESG goals and how important they are to companies right now, especially, with companies now reporting on their sustainability goals. So, I mean, I and the way I think about this is that, like, if they really are serious about meeting those goals, they're not going to be able to do it without real-time data, right? So, I mean, how do you see this issue of ESG sustainability for driving adoption of things like RealEstateCore?
Well, I think again, when we're taking a bigger perspective. I mean, we are several both countries and organizations that has the goal to be carbon neutral by 2030. It's less than 100 months, so it's basically 1% per month that you have to achieve to reach that. And then you understand that traditionally, when you're doing these kind of ESG certification, it could be like 3 years intervals. And what is happening now when organizations such as US Green Building Council is using data connected data, real-time data, is that you get the possibility to automate it, which of course saves lots of money, makes it possible to certify more buildings and find more issues. But I think the second thing, and as David said, is that when you start using this data to improve, not waiting for getting the certification every 3 years, but you're doing this continuously. So this will not just be a tool to comply, it will be a tool to actually improve continuously. I think that is the big win. And then again, RealEstateCore bridges over, because when it comes to ESG, it's not just kilowatt hours and cubic meters of water. It's actually also the wellness of the user, of the tenants, and there is waste. There's lots of other data points which are not typically technically oriented, but rather more where RealEstateCore covers.
Yeah, and there's some excellent points there. Good. Okay. Well, let's move on then with our final presentation of the RECcon21 conference, and this is going to be called Conceptualization of AI into Indoor Climate as a Service based on RealEstateCore. And this presentation is going to be given by David Helleberg. He is energy researcher at academic Hoof. He is an experienced leader with a demonstrated history of working in real estate industry with energy and load management, HVAC, automation, etc., to use digital information to define new sustainable business models. David uses different machine learning techniques to develop systems for energy optimization and automated fault detection and diagnostics. Great. Well, take it away, David.
Hi, thank you for inviting me to the RealEstateCore conference. My name is David Helleberg and I work for Akademiska Hus. Akademiska Hus is one of the largest property companies in Sweden and managing almost 3.5 million square meters of university buildings, where 30% consist of laboratory buildings. In my role as an energy manager, I manage people and projects towards our goal in 50% in energy reduction between 2000 and 2025. In this presentation, I will give you a short introduction to my ongoing research project at KTH. My research at KTH started in the energy field, focusing on automated building performance optimization, in which has evolved into the development of the concept of Indoor Climate as a Service, ICS. ICS is a customer-oriented business model focusing on delivering high-quality indoor climate at minimum amount of resources as the driving objective. It's hard and software agnostic framework for implementing a moderate level of digitalization, including AI and machine learning, to address the property owner's most challenging question: how to deal with the climate crisis and how to become more customer-oriented. Why? There are 3 strong reasons considering ICS. First, servitization. The building sector is experiencing a rapid transformation driven by digitalization, climate change, market policy, which has resulted in new traditional market actor and an energy service has started to emerge. Digital innovation is reshaping the way most industry and businesses are functioning today, which forces the property owners to rethink our existing business models. Second, decarbonization. There is a significant energy saving potential within a sector responsible for around 40% of the energy consumption and 36% of the CO2 emissions in the European Union. A sector that is also a large contributor to the peak demand and plays an important role in the energy transition towards 100% clean energy. And digitalization. Recent advancement in cloud computing, IoT, sensor technology makes it possible to collect and store large amount of time series. One of the sectors that has greatly benefited from this advancement in big data is the building science. The use of AI, machine learning, deep learning, analysis have proven to have remarkable impacts on various research domains, such as building energy forecasting or pattern recognition. Indoor climate as a service. It's focused on optimizing customer satisfaction and value based on long-term, real-time verification of key contracted indoor climate parameters. The concept utilizes big data technologies, allowing the management of individual building performance to better synchronize with performance requirements for larger districts, such as campus level. It is hard and software agnostic, but developed in order to be scalable to other climate parameters or buildings. It serves both as a tool for advanced automatized control for building performance, as well as a competitive business model for the property owners to stay relevant in a platform economy. How? The concept is developed and contracted and fully implemented at KTH campus in Stockholm. The first case study building on the left side in this picture represents a modern office building from 2005 with up-to-date building technique and energy performance. The second case study building was built in the late 60s, but is continuously updated, of course. But it still suffers from a bad indoor climate quality due to insufficient climate shell. And both of them are well documented in my previous published papers. And the whole process and the concept, including the business model, the smart building platform, and AI for system performance optimization are visualized in this picture. The process starts by defining the indoor climate and contract the service. That is shown in the yellow section on the left side. The indoor climate is defined in every contract depending on the user's need and the building technical potential. It's typically a minor part of the whole spectrum of indoor environmental quality. The definition and the level of quality determines the sensor technology, future investment cost, and building future energy demand. The concept is self-financed by future energy savings, including the implementation cost and future energy investments. It's contracted as an appendix to the existing leasing contract, but the goal is to be a part of the next generation standard leasing contract. The data integration, the use of RealEstateCore, and the smart building platform is visualized in this blue section. The sensor data, operational data, energy data, and weather data are organized and managed on a Microsoft Azure IoT Edge cloud solution, visualized on the right lower part of the picture. That's the building side of this picture. is a data platform based on RealEstateCore version 3.1 for two-way communication. Data from the building automation system and the demand control system are extracted according to the configuration specified in the RealEstateCore tag list using IoT Edge module running on the IoT Edge device physically located in the building. The building automation system and the demand control system communicates by Modbus TCP, and data are translated using IoT Edge modules. The module function is to pull the source system according to the configuration specified in the RealEstateCore tag list. The REC tag list differentiates between a sensor that represents a read operation and actuator that enable the writing of values back to the Modbus register and further back to the building system. The weather and the energy data in the cloud is processed by a data factory that triggers every hour. This solution manages almost 5 million data points every 24 hours. Then can enable AI modules for processing big data to return feedback signal. A lot of time in this project was spent ensuring the quality of the streaming data. The data set in the Azure platform generally suffer from two types of missing data. First, sensors were not recorded at randomized time interval, or sensors were not recording data continuously. Several data imputation techniques, both statistical and prediction-based, were explored to impute the missing data within this project. The last part, the AI, or Automated Building System Optimization, which enabled several types of AI in this framework, is visualized in the transparent part. The process including for energy model or demand response could, according to the literature, be categorized in black box, gray box, or white box. The white box as a physical-based approach based on prior knowledge and expert knowledge, where models are identical to actual object is created. The outcome is dependent on the expert knowledge and the level of details in this physical model. The vast majority of the existing AI for building optimization are based on physical models. Black box are purely data-driven, where the algorithm is created based on historical data. The gray box is a mix, where rule-based methods from the physical methodology or are combined with data-driven approach. The main advantage of data-driven in comparison to physical-based is the simplicity and the lack of less engineering effort. It's easy to scale to other buildings. A drawback is the need for high-quality data and the lack of transparency. Data-driven predictive control, called DPC, has grown dramatically in recent years due to the development of machine learning and big data, and seems to be the most appropriate tool for data processing in this concept. The DPC is designed as a supervisory control strategy that provides set point recommendation to the building. Data-driven models built with large data set often have overfitting issues and high computation cost. A systematic feature selection process that selects the feature that with the best model performance is implemented to this case study. Since most buildings are operated under a very limited operation modes, weather condition and control set point, the data-driven model trained using the data have often poor accuracy when forecasting unseen conditions. So, to generate more information, training data and active learning procedures implemented in this project. The objective of the DPC is to minimize the building energy consumption during forecasting horizon while maintaining a defined indoor climate quality. The goal of this DPC framework in this project is to maintain a zone temperature between 21 and 26 degrees C during occupied hours and 19 to 26 degrees C during unoccupied time, while minimizing the heating energy consumption. There are of course also another energy model for the cooling season. Entire process is fully automated, but is in this process based on manual work for sending control due to a temporary firewall restriction. So every 3 hours, new set points are determined using this AI-based supervisory control tool, including feature selection and active learning procedure. The air handling unit supply air temperature with between 15 to 19 degrees C, and hot water to radiators supply between 22 and 42. DPC are tested and fully implemented on October 22nd and November 7 and November 8. And the results from the unoccupied period. There are two graphs shown in this picture. During this DPC implementation, the left graph shows the different energy demand between forecasted baseline operation and operation under DPC framework. The right graph shows the indoor temperature. The DPC framework indicates 82% heating energy savings, meanwhile maintaining acceptable indoor climate. The new set point is the result of combining sensor data, weather data, forecast, and building thermal mass. What we did, or what the DPC did, was lowering the supply temperature on the hot water radiator circuit, and that would decrease the energy demand by 82%. During occupied time, some of the zone temperatures were below the temperature constraint of 21 degrees C during occupied. It forces the DPC model to increase the radiator temperature. Since ICS focus on comfort, where some feature for some period of time could instead increase the energy demand. The DPC framework, including the Microsoft Azure IoT Edge solution with machine learning on the edge, are developed and is not right now evaluated from a cybersecurity perspective. And it's also evaluated from an organizational side of view, where we as an organization try to understand, get a deeper understanding of how artificial intelligence could contribute to our building performance. And also we understand the importance of energy data, of high quality. Next step. Data labeling using RealEstateCore ontology was useful, connecting the signals to specific objects or processes during the work with ensuring the data quality. RealEstateCore automated the building system optimization by enabling control for the building automation system and for the demand control system. The lack of transparency using the black box mentioned before was managed by RealEstateCore activation interface, where different set point interval regulated the feedback signal. ICS is a hard and software agnostic tool, but sticking to the RealEstateCore could empower the onboarding process for upscaling. Thank you so much for listening.
Okay, excellent. Thank you very much, David. And that wraps up our last presentation for RECcon21. So what did you guys make of that? I mean, I think what I hear, or what I could take away from that is like a really practical example of using RealEstateCore to develop an AI model for energy optimization and fault detection. So, I mean, from your perspective, what do you see as the benefits of how he's using RealEstateCore?
Yeah, no, but I think this is where we actually, if we're going back to the data chasm, this is actually where you see how how also David had struggled with actually getting the data, cleaning the data up and having it usable. And I think here is really one of the strengths of RealEstateCore, that you then can use it. I mean, RealEstateCore also has a spatial description, so you know where things happened in the building. So you're actually giving the machine learning guys and the data scientists, you're giving them the work with your problems instead of spending lots of time of cleaning up the data.
Yeah, and I think not only in terms of spatial placement, but basically any type of contextual information that you may want to add when preparing your data for some machine learning or other AI task. Is, you get your sensor data, which is comparatively sparse and lightweight, and then you can use the digital twin graph, the building graph expressed in RealEstateCore, as a dictionary, if you will, or a lookup mechanism to contextualize that data and add more detail and add more richness that your analytics may need, whether that is in spatial placement or some other context that may be relevant. So I think this is a great example of how RealEstateCore can support and may even, well, something like RealEstateCore may even be necessary for various types of analytics. So yeah, very, very powerful stuff.
Good. Well, that wraps up all of the presentations for RECcon21. Of course, thank you to everybody, including you two, for presenting today. I hope that everyone found that useful and informative. And of course, you get the information that you guys want to understand what RealEstateCore is and how you can use it in your own projects. So, I mean, guys, let's wrap this up. Be interested in your final thoughts on today and what we presented, and what I guess you want the audience to take away.
Yeah, so I'd start with saying that we have something here which we think is quite powerful and quite useful as is, and which we've developed with several partners and companies and individuals. But we really want this to be a community process and a community development here. So we'd love for you guys to join us and help us in building this, and to bring your problem domains into the space that we try to solve. There's plenty of things we can do jointly. So please join the consortium or join our chat channels or our GitHub repository and all of that, and come along with us and make the world better.
Yeah, that's right. And I think, again, as we said, that we need to have the buildings, we need to have the APIs of the buildings. And I mean, that is what RealEstateCore is facilitating. This is a too big task to solve by ourselves. We really need to find the kind of interaction, the surfaces of where we can do this together, and make the smart city come true. Basically.
Exactly. Yeah. Great points. Well, look, thank you both for your contributions today. Thank you to everybody, of course, for listening to us and the presentations, and everyone who presented. So I'll leave you with some points of action here. I think first of all, and just to echo what you said, Karl, number one, if you want to participate in the community, you want to look at the code, there is a GitHub repository. So if you go to github.com, RealEstateCore/rec, there you will find the code, and you can get into that. And I think you can also make comments there as well, right? If you want to join, go to the RealEstateCore website and the member page there. You'll be able to do that. And then finally, presentations from today will be available at some point soon. And if you go to the again, our website, you'll be able to find them there in some soon. Also, you will be able to sign up for a newsletter. So we just encourage everybody to get involved in this open source project and contribute. So again, thank you very much.
Yeah. And don't miss, so you don't miss out ReCon22.
Exactly, of course. ReCon22 will be coming up next year. So look out for that as well. Thanks again.
Thank you.